All right, I just want to make sure that we're comfortable doing this. So this is example 2. What I would encourage you to do, if you're following along with the videos, pause right now and answer all these questions. And then press play and see how I do it. I'm going to work through this problem a little quicker since I explained everything in minute detail in the previous problem. So if you need more of the details, go back. So again, here we go. Hopefully you've paused. You've made an attempt at this. The vertical asymptote, where the denominator is 0. So x plus 2 equals 0. That means the vertical asymptote is at the x value, -2. The horizontal asymptote. This is the situation where the degrees are the same. So the horizontal asymptote is the ratio of these coefficients. So 2 over 1. So that makes the the horizontal asymptote 2. The y-intercept is what I get when I plug 0 in the function. So I've got 2 times 0, or 0 plus 1 in the top, and then 0 plus 2 in the bottom. That means that my y-intercept is 1/2. The x-intercept is when the rational equation equals 0. That's what my y value. And so again, my fraction is only ever 0 when the numerator is 0. So when 2x plus 1 is equal to 0. Subtract 1, divide by 2, you get -1/2. Does the graph cross the horizontal asymptote? So let's see. So I'm going to take my 2x plus 1 over x plus 2, and I want to know, is that equal to the horizontal asymptote value of 2? So once again, I'm going to go ahead and I'm going to multiply both sides by the common denominator. 2x plus 1 is equal to, when I distribute, 2x plus 4. And once again, just like with the previous problem, when I go to bring the 2x to over here, I end up with the equation 1 equals 4. That is that is a contradiction. That's never going to be true. So the answer to this is no. So once again, I can trust that the horizontal asymptote is firm. So now I'm going to plot the information I have. The vertical asymptote happens at -2. So here we go. The horizontal asymptote is at +2. So once again, that tells me so much information. My y-intercept, where it goes through the y-axis, was 1/2. My x-intercept, where it goes through the x-axis, is -1/2. And so once again, you can see that the right side of this, since these asymptotes are both firm, the graph is never going to go through it. I can complete to the left side of this graph like so. Oh, that's beautiful. Graph of the year. So all I need now is 1 or 2 or 3 points that are less than this vertical asymptote. I will again get 2 just so that you have enough information. Get more if you need them. So I'm going to go back to this other board right here. So since my vertical asymptote is at -2, I'm going to find the function value at -3, and let's go -6. Okay. I have no secret reasons for choosing these points, so pick whatever you want. So here goes. When I put -3 in, 2 times -3 is -6, and then -3 plus 2. So that gives me -5 over -1, so the value is 5. So at the x value -3, the y value is 5. When I put -6 in, 2 times -6 is -12, -6 plus 2. So I have -11 in the top, -4 in the bottom. So that's +11 over 4, or in other words, 2 3/4. So finishing up my graph. When I plugged in the x value -3, so 1, 2, 3, I got +5. So 2, 3, 4, 5, make a dot right here. When I plugged in -6, so 4, 5, let's see, 1, 2, 3, 4, 5, 6, right here, I got the value 11 over 4, or 2 3/4. So just a little bit above the asymptote. And so my graph looks like, remember, don't draw your graph, don't overdraw it. You don't want to go through the asymptotes. You don't want to curve back around. That's a common mistake. This is just a sketch. It's to get a picture, a feel for what it looks like. It doesn't have to be perfect. There you go.